Can you hear me? Okay. Hello, everyone. So, I'm Anthony, currently working at Algolia for more than a year now. And during the last year, we decided to move on and build the new log processing toolchain that is used at Algolia internally to mostly generate the metrics that we are providing to our customers, but also to help us do intelligent data analysis on top of it. For those who don't know Algolia already, Algolia is an hosted search engine. So it's a typical SaaS company. Basically, you send your own data to us. We received it, we indexed it, and out of this, you just have to configure the ranking. And then you have to build your own UI on top of this. For this, we are providing a lot of frameworks and libraries. And thanks to that, you can build a lot of great search experience, such as the one that you may have seen on Twitch, Periscope, Birchbox, and others. So I'll stop there for the presentation of the company, but if you have any question regarding that, I highly recommend you to talk with us at the booth during the breaks. Just to give you a little bit more context, so in 2017, the numbers, we are at more than 100 employees across 4 offices. The 2 main ones are the San Francisco and Paris offices. And we are more than 2,800 customers. Last month, we served more than 100 billion search queries during the month. And on average, since January, we are at around 66 billion queries. So, as you may guess, the central piece of the Algolia search engine is the API we are providing to our customers. On top of this, we are also providing the monitoring API, which give customers quick access to their own metrics. So, for instance, the state of the machines, also the number of query per second they are performing across an hour, the number of search queries, the number of objects they have in their indices, and that kind of things. So this is the main API that we will talk about today, because the log processing toolchain we have built today and that I'm presenting is actually replacing all the part that is computing the metrics behind this API. We are also providing an analytics API. So as I will present to you later, this is something that will probably evolve in the following months. And this is the piece that you need if you want to understand the queries from your users. So for instance, if you have, let's say, Twitch, so Twitch is a video game company, and all your users are looking for League of Legends, very famous game, and you see that for this specific query, you have no result. Okay, this is the kind of information that you can have thanks to the analytics API, and that will probably help you understand better your data and correlate it with what your users are actually looking for. For the infrastructure, we are located across 15 regions across the world, and in about 51 data centers. One of them is in Amsterdam, and we had the chance to visit it yesterday, so thanks to Liz Webb. And it's roughly about 1,000 machines now. Now to present you the stack. So the search engine is pretty simple. On all the production machines that we have, we are running the search engine by itself, which is a C++ module that is compiled against Nginx, and we are running here. We have very few running processes on production machines, and you will understand later that actually we have introduced a new one for the new log processing toolchain. In the past, the log processing was composed of essentially two things. The Java code that was actually computing the metrics, and the Scala endpoint, which is there just to simply expose the metrics to our customers. The Java processing was running on a single machine, single dedicated machine that we have, and the Scala endpoints were running on multiple EC2 instances at AWS. So now let me introduce you what we had before. So this is the rough schema of what we had. Here you can recognize the Algolia API servers. So they are pretty much all the same. They have the Nginx built with the search engine in it. And they are generating log files. So those files are really simple. They are only text files, logging every 5 minutes all the incoming queries to the search engine. Then we have the log fetcher, which is running on the log processing server, the unique machine I talked to you earlier. This one is taking all the logs from all the machines and producing the metrics that are then just put in an S3 bucket. It also copies all the log files onto the disk of the log processing server, because the analytics toolchain, so the one that I will not present today, is still using those files, and it needs to have access to all the files in a single place to process it. This is not something that we will keep in the future, but okay, for that time we had to at least reproduce this. And finally, we have the monitoring API, which is the Scala endpoint I discussed earlier. Now, let me talk about the market studies we have conducted for this, because, okay, this is interesting to play with new tools, new toys everywhere. But actually, when it comes to the price, you have to present something serious to the company first. So we conducted a small study between SaaS companies and platform as a service. The reason to choose a SaaS product in the first place was pretty obvious for us, because Algolia is a SaaS company and we are a search engine. We are not a log processing company. So for us, it was totally fine to delegate this work to a company which is only doing that, and that knows how to handle their servers, knows how to process it faster, etc. So for that, of course, we were limited by the price. So at the time we started the project, it was limited by a certain amount for monthly revenue. This was the data and requirements that we sent to those companies, so multiple companies actually, last year. So we were roughly generating 2 terabytes of logs every day, uncompressed. And it was approximately 1 billion lines of logs. So it's not a lot when you think about, okay, this is just across one day. But actually, the logs are pretty complex. They are composed of nearly 25 key pair values. And you also have to think that when you are getting those logs, you have to generate per hour metrics. So it's near real time, so you have to process it fast. In the past, we had 1,500 customers. Today, it's nearly 3,000, as I said. So you have this granularity to also take into account. Each customer can have one or multiple applications, and each application can hold one or multiple indices. And you have metrics for every single one of those filters. The first result that we get from the SaaS companies were actually, okay, we cannot do this for you. Others told us we can do it, part of it. We never did it, but we can try something. It won't be exactly what you want. You will have limitations, but you will have it in some way. And it was at around 14,000 euros per month. So definitely out of our cap. Others were saying, okay, we can do it. You will be one of our biggest customers, but we can do it, and it will be 500,000 a year. Once again, not possible for us. So they were pretty much seeing us like the big pile of cash for this. And we were just saying, okay, guys, you're super nice. They were super effective for the sales job, and discussing with the tech team was really easy. But we decided to move on. So we conducted a second market study, this time with multiple PaaS providers, AWS and GCP. You won't see Azure in here because we were planning to use one of their common products here, which was not available with Azure at this time. They offer pretty similar products, the two of them. The main thing that you have to consider is that AWS is running open source software for you on-premise, and GCP is just providing you battle-tested software on their own infrastructure that they have built internally first, and then sometime they release it as open source. Really think about it if you want to build your own cloud-based software stack, because with GCP, sometimes you may end up with a little bit of lock-in, which is not really cool if you plan to move to something else in the future. Pricing is super difficult in both cases because, okay, you take the page of the pricing for every single product that you plan to use. You have one price. Then you do the same with the pricing estimator that they are offering you. You have a second price. You don't understand what's happening. So you call the sales rep, and they'll give you a third estimation that is totally different from the two third ones. So yeah, pricing is difficult, and it's something that you will have to spend some time to understand. In the end, we decided to move on with the GCP. At the time we conducted the study, the sales were super effective with us compared to AWS. Not saying that one is better than the other, but at the time we were doing the experimentations, it was a big deal for us. Also, in our case, we discovered that GCP was cheaper. It's something that may also impact when you are discussing with the other guy in your company that are signing the check. And we also felt that the documentation was really better with GCP, easier to understand. And as a developer, it's always something that is preferable. So, now that we have conducted the studies, let's talk about the actual thing that we did. So this is the old log processing toolchain I've already presented you. We have done two projects to replace it. The first one is the one that is actually fetching the logs from the machines and producing the metrics somewhere, not especially in the S3 bucket. And the second part is to actually reproduce the log fetcher writing on this part to feed the analytics processing that we won't replace for now. For this part, we introduced Dobby, which is the little house elf that is processing all our logs at Algolia now. It's only handling the log fetching part, so taking the logs and putting them somewhere. The main goal here was to use less resources on API, as less resources as possible on the API servers, because okay, the API servers are there just for our customers. We don't have to impact this part. Also, previously we were only able to fetch the logs from the machine, and that's all. By introducing Dobby, we wanted to be able to send to multiple consumers, also control the compression and have a better understanding of what's going on under the hood. And this is what we did with Dobby. For that, we used Go. So most probably some of you are already familiar with this language. The reason for that was that at the time we started the project, one of the devs was already proficient with the language. It was me in this case. And I find it really easy to learn and really easy to maintain on the long term. I was already playing with it for 1 year in my previous company. It has very low CPU and memory consumption, and things are easy to understand. You have not a super complicated stack when it comes to debugging. And the fact that it was statically linked at compilation It was really good for us because it just means that, okay, compile it for our servers that are all the same at Algolia, and boom, you just copy the binary there, run it, nothing to install. Super cool. This is the new toolchain we have with Dobby. So it's in 3 steps, actually. The first one is that on the API server, we have no Dobby instance that is running, called the Dobby producer. This one is just here to fetch the logs locally and push them to the Dobby consumer. The Dobby consumer is running within a Docker container on a Kubernetes cluster that is hosted by GCP for this. And it takes all the logs that are incoming and write them to storage, Google Cloud Storage, which is the AWS S3 for Google. The advantage of using the Kubernetes cluster is that now we can start as many pods, as they say, as we want, so as many replicas of the same Docker container on the same cluster. And the load balancer of Google in front is just feeding them, and as they are all stateless, they are all doing the same job. Once we have stored correctly the logs for the same 5-minute interval for one machine at Algolia, we then send a message to PubSub saying, okay, those logs are safely stored on storage, use them to process them later. PubSub is just the message queue that you use at Google. Finally, we have the Dobby downloader instance. This one is running on the log processing server we have seen earlier. It completely replaced the log fetcher because it's fetching the message from PubSub. And out of the message, it knows exactly which logs are available on Google Cloud Storage, download them, and put them on disk for the log processing, for the analytics processing. And that's all. Went well. Actually, this is running in production for more than a year. It was really easy to maintain. And when I say maintain, it's even easy to make it evolve, because this is the very last architecture that we have for this, but this was absolutely not what we intended in the first place. So yeah, it was really easy to iterate on. I think it's part of the reason is because we choose Go for that. And easy to deploy. As I said, as everything is statically linked, you just compile it, take the binary, we put it on S3, and then all the machines are fetching the new binary via Chef and run the new version. What went wrong? 2 things were actually very funny to debug. The first one was the use of the LZ4 package. The LZ4 package we are using is an external one, not part of the standard library. The problem with that is that I benchmarked it at the beginning, discovered that the performances were fine, compression ratio was better than gzip. So in that regard, we were pretty happy with it. So we used it for some time, and at some point we discovered that we had huge CPU spikes consumptions. Because of that, we decided to benchmark it a little bit. And when we investigate, we discovered that actually the decompression part was really efficient, not consuming a lot of CPU, when you decompress one log at a time. The problem with the consumer is that it decompresses a lot of logs at the same time. And the way they were implementing LZ4 in this package was not that good performance-wise. And by just replacing it with gzip, which is part of the standard library of the language, we gained a lot in terms of CPU and memory consumption, and the compression ratio was kind of the same. Also, the second problem we have with this is that we are not solving the log processing server problem, which is, okay, we still have to store all the logs on this machine to serve the analytics part. This is something that will evolve in the future as we will change also this processing step. So, as I said, the first part is done. Now I will talk to you about the second part, which is, okay, we have reproduced the existing pipeline for the analytics toolchain. Let's now think about how to process more efficiently and more reliably the logs that are incoming from the server to actually generate the metrics. And this is where Logwarts comes in. So Logwarts is our new log processing toolchain. As we are a big fan of Harry Potter's in my team, we decided to be a little bit fun with the names. The main goal here, of course, is to be more resilient and more extensible. Resilient in the sense that, okay, we won't run this on a single machine anymore, obviously, and extensible because previously the stack was only handled by one person at Algolia, which wasn't really cool, slow to evolve. So this is something we wanted to address too. And this is where we started deciding to use Dataflow. Google Dataflow is a product of GCP that lets you schedule basically huge MapReduce jobs, but you don't even have to think about the infrastructure behind it. You don't have to deploy your own Apache Spark, your own Hadoop. No. Here, you just say, okay, this is the job I want to run. And from this, compute the metrics that are from this place and put all the results in this place. That's all. And Google Dataflow will basically start the VMs for you, auto-scale them if you want, and just process the metrics, the files that you want as an output. And this is also the place where Scala is coming in. The reason this time to choose Scala was that the other person that was working in my team was already proficient with the language, so we decided not to introduce something totally new. Also, a big constraint with Dataflow is that the main language that you can use is Java. There is a second one, you can use Python, but I think it's still experimental, so not really ready for production use. And finally, we discovered that there is a Scala library called Seure, made by Spotify, that is exactly a wrapper on top of the Java SDK for Google Dataflow, helping you to do way more things and express things in an easier way. So that's why we decided to use Scala in the end. This is the new pipeline, so bear with me, it's not that complicated. Just keep in mind that I've just trashed the part on the left that is producing the message in PubSub and writing the logs to storage. But we are just starting from there. The first part is RE-logger. So RE-logger is processing the logs, obviously, or at least preparing the jobs that will run on Dataflow. Let me explain. The first thing that RE-logger is doing is fetching the messages that we have seen earlier from PubSub. From there, it crafts a job that we will run on Dataflow. It then sends this message to run, which have a job of running the Dataflow jobs. It's just taking a lot of those messages and start Dataflow jobs out of this. Dataflow jobs are just taking the logs that are available on storage, actually starting machines from Google, start to do the computations, and generate aggregates on storage. Because, as I said, we are generating a 5-minute range of logs, and in the end, we want per hour granularity for our metrics. So that's why we are generating aggregates, which are intermediate results that we'll then group to have the final metrics. Once those jobs are done, Ron is aware of that and send a new message to PubSub saying to aggregate, which has for the job to aggregate the logs. It just does exactly the same as RE-logger. It just takes those messages, the new messages, and craft new jobs around it that it then send back to Ron. Ron is then taking the aggregates, starting those new jobs, and produce the final metrics in Bigtable. Finally, we had to plug the existing monitoring API to Cloud Bigtable instead of the S3 bucket before. What went well with this project? At least we have something that works at scale. This was really the best improvement for that. It's relatively easy to deploy. We just have to start new containers in Kubernetes. Everything is fine. It's extensible. So even if we are only 2 at the time to manage the log processing toolchain, the code is pretty simple. It's less than 6,000 lines of Scala, or 7,000, I don't remember. So it was really understandable. And at least no more single point of failure. What went wrong? A lot of things, actually. At first, we started the project by running our jobs on Dataflow in streaming mode. Dataflow is able to run everything either in streaming or in batch processing mode. The streaming mode lets you start machines that will continuously fetch new inputs and write outputs indefinitely. Actually, for us, and I think it's a common truth, streaming is way more expensive. So we decided to move on with batch processing. And by using batch processing, we have to redo all the scheduling on top of it, which took us a lot of development time. We also discovered a lot of Google quotas and limits. So those are soft limits and soft quotas in the sense that once you hit this limit, you can still discuss with the Google sales representative and explain them why you need to go above those limits. And they are pretty keen to help you in that regard. But still, you just discover those limits when you are on the edge of pushing something new or when you have a spike, and this is not the moment you want to take the phone and, or send an email. Also, Dataflow is pretty young, so you won't have a lot of help on the internet. It's a product that is only managed by Google. Today, it's less true because they are moving their SDK to Apache Beam, which is the open source version of it, which is really cool. But still, you won't have a lot of help on Dataflow besides the sales representative and the support. Also, Scala is pretty difficult to learn in the first place, more difficult than Go. It has a lot of interesting features, but we have to onboard people on this, and I was the first one to be onboarded on that. So, okay, this was really something that took us a lot of time. And finally, handling lateness. So this is not because of Dataflow, it's just that it was really a problem for us. Because at some point, the single log processing machine that we had in the past was sending us all the messages. When this machine crashed, we had 3 really interesting days to recover the machine and restart everything on a new machine. And from there, it started to send all the missing logs that we missed during those 3 days. This is the huge spike that you see at the beginning. And during a few days, Dataflow was actually starting all those jobs to catch up. This was super expensive because all the VMs were running for that. We are paying a lot of money. And at some point, we discovered that because of the way PubSub allows you to re-enqueue the messages that are not acknowledged fast enough, we were doing multiple times the same jobs from time to time. It was super expensive for us because we moved from $200 per day to something at $2,500 per day. So at that time, we decided, okay, let's do something about the grouping because it's really bad. And yeah, we changed it. My talk should have stopped here 1 month ago, but actually we were not super happy with going in production with that. Dataflow was still costing us a lot, like $9,000 a month. And this is without the cost of PubSub, Google Cloud Storage, the network ingress and egress. And as we have seen, on average, we were running 48 non-preemptible machines for that. So non-preemptible because for now, at least for now, Dataflow doesn't let you start preemptible machines. And okay, we are really starting nearly 50 machines to run the exact same processing things that what we did in the past with one single machine. Okay, maybe this is not the smartest way to do, smartest things to do. Also, when you are starting and stopping the VMs for Dataflow, you are paying for this time. You are not only paying for the CPU time, you are actually paying for the time the CPU are not available for other customers. And starting and stopping all the machine every 10 minutes is not super smart. Even the sales guys told us, okay, you are doing micro batching, it's bad, it's bad, it's bad. So 1 month ago, we thought, okay, what if we are not using Dataflow anymore, actually? This is a huge constraint. mostly because of the language, but also because of the price. And only 2 people in the company were knowing Scala. So, okay, we doubled the amount of people on the log processing toolchain at Algolia, but still, not very cool. So we decided to just do a simple POC and completely trash data flow and run everything in Kubernetes. Needless to say that sales were not super happy with this. But okay, business is business. So the thing is that we just did all the computation for the iLogger jobs and Agrid jobs directly in Docker containers. So without using data flow, we are not scheduling the jobs anymore. We are actually doing the jobs once we were receiving the message from PubSub. That's all. We reduced the cost by a factor of 10 by doing so, just because, okay, now we just have the machines for the Kubernetes cluster to pay for, and we were able to start preemptible machines because everything is timeless, is stateless. It was rewritten in Go also because we decided it was an easier language to maintain on the long term. In the future, what we gain is that we have a better expertise internally with Kubernetes and GCP. We are finally doing good monitoring on top of all the log processing toolchain. And we have more people able to work in Go and Scala, and we are hiring more and more people already knowing Go, which is cool. And we have also, during this journey, we have found the pain points regarding deployment at Algolia, so we will probably change that in the future, in the next months. Also, if you are going with those products, whether it's AWS, GCP, or Azure, don't forget to ask for support, because okay, you won't find a lot of information online. The support is really here for that. Finally, we are currently trying to improve the deployment. We are thinking about the next step for the analytics API that is still running on the log processing server. And at least we can refactor everything, because once you have a big project that is in production, stable, and you are sure everything is working, it's also the time to think about refactoring, because maintainability is also the key when you are designing software on the long term. Thank you for your attention. If you have questions, I'm not sure we have the time.